Hey coding buds, so basically in today's GFG POTD we have a problem, symmetric tree. So basically it is a easy life problem, and as the problem statement is given as, given the root of the binary tree, check whether it is symmetric, that means whether the tree is a mirror image of itself or not, okay? And here the second statement is given as a binary tree is a symmetric if the left subtree is a mirror reflections of the right subtree. So basically in the given problem, we have a binary tree. We know very well about binary tree. Those tree which is having almost two children, that means either 0, 1 or 2, that's are called as, we can say that, binary tree, right? So here we have to check whether the tree is like symmetric tree or not, and how we can check if the left portion of the tree is like, if it is like exactly equal to the, we can say that, second half of the tree while folding, we can say it vertically, then we have to check, okay, we have to check whether it performs mirror like images or not. If it returns the mirror like structure or mirror like image, then we can say that it performs or it forms symmetric tree, okay? So here if you're talking about the first example here, so here we can say that 1 2 2 3 4 4 3, so like it is like in the form of this, okay? And if we, let's say if we're like folding this tree, then we actually getting one at their own place, 2 is like placing at this place, 3 is like placing to this place, which we also getting an image in the form of mirror, okay, or inside the mirror also, okay? So here we can say true, as the left and the right half of the above tree is like mirror image, tree is symmetric, okay? But if I'm talking about the second example here, so while folding this, or like if I'm looking at the first half of this tree in the mirror, we actually not getting as in the form of second half, so here we have to return false, okay? So we have to solve this problem with the time complexity of, like we can say that, time complexity of order of n and auxiliary space of order of 8, okay? And this question is like asked in Amazon and Microsoft type of companies, and this is like completely based on trees and data structures. So first of all I'm going to solve this problem here, but before that I need to also explain it about the approach here. So basically this is the tree here which I've drawn, and this is the example one here also. So what I'm going to say here, like if I am just like doing these things, if I'm going to look at the mirror images, okay? So if I want to like watch my first half, okay, this is my first half in the mirror, okay, then I'm getting the result as this one, okay? So if I'm getting this mirror images, that means we actually getting symmetric tree, okay? And if I'm getting symmetric tree, we have to return true, okay, as this function is returning boolean type of value, so we have to return true. So what how to solve this problem? First of all, in the first step we have to check whether there any children element is present inside the tree or not, or we have to simply say that first of all we have to check the base case, okay? Check the base case, okay? That means we have to check for root node is present or not. That means checking for root node, okay? Checking for root node, okay? So how we can check? If root is equal to null, okay, that means if there is nothing, that means the tree is not present, okay? Instead the root is also not present, then there we have to just simply return, okay, false. Okay, not false but true, okay? Because we can't able to like uh, check the mirror images, okay? So in that case we have to return true, else we have to return what? We have to return we can say that here we have to create another functions which are basically to check the tree is whether it's symmetric or not, okay? So here we have to make some type of functions which are basically to check the root element, which is basically checking the left node as well as the right node, okay? So I've created these things. Now this is basically checking in the second example, in the second step here we have to check for the left node and the right node, that whether they are symmetric or not. So now in the second step here I need to create another function, okay? So I'm creating another functions that are basically to check the symmetric tree or not, okay? So inside second step what I can say here, checking for the child nodes. Okay, now once we have confirmed that we have a root node. Now we have a root node, and we have to check whether we have any children nodes or not. Okay, so bool function name is like check here created, and then inside that we have to create node star left. Okay, and node star right. Okay, node star left and node star right. Inside that we have to check, first of all we have to check whether the tree is present or not. Okay, so we have to like place this second step here. Okay, so we need to check if left node is like equal to 0 and right node is like also equal to 0, that means root node is present but the children's is not present, then also we have to return what? We have to return true in that case also. That means we have only root node, so it is considered like symmetric tree. Okay, if we like looking out at the image or like mirror also, then we actually getting the same mirror images. Okay, that means it is a symmetric. Else what we have to do, we have to check for the children's node. Okay, let's see if children is there. Okay, in the third step I'm going to check if there is any, if root node as well as child node also present, are also present, then we need to check whether they are like forming symmetric images or not. Okay, so what we can do here, we need to check if left is equal to 0 and not left is equal to 0. Let's say if there is any children, so for that what we can do, if left data is present and right is also present. Okay, if left present, okay, and right's value present and logical and, but let's say if left is like not present or if left's data, okay, here what we will do, here we need to check if left's data, okay, if left is like equal to left value and right is like equal to right value, and if left's data, okay, if left's data is not equal to right data, then here we have to return false. Okay, then here we have to return what? Here to return false. And how we can say that? That means here we have a value that left is like pointing to left node, right is also pointing to right node, but if left's data is like not equal to right data, then here we can simply return false. Okay, so at the last step we need to check, okay, here we have to return this function, what are we actually making here, what are we just here function call here. Okay, so again we need to make a function, let's say check. Okay, if here left, here we can say that if left's data is like equal to right's data, okay, that means performing mirror images, and check if left right or right left data. Okay, so here we have to return true, but here one thing which I think I am doing mistake, if left data, okay, and if right is checking for right data, if it performs like mirror images, and if left's right value is also like equal to right's left's value, then it will return mirror like structure, that means it will return true for the symmetric tree. Let me compile and run this code. Okay, so yeah, here comparison is completed. Let's try to submit it. Okay, so we have done something wrong here, and what it will be, if left is equal to 0 and right is also equal to 0. Okay, so here what we will do, if left is equal to 0, here we need to check what. If left, I think here I need to modify this condition here. And how we can do this thing? If left is equal to null, let's say I'm giving the same condition here. If left is equal to null, and or, not and but or, okay. And if right is equal to null, or if left's data is not equal to right data, then you have to return false. Let me try to compile and run again. Here, let's try to submit it. So it's submitted. So yeah, that's all for today. Thanks for watching.